Okay, 7.4 is the beginning on how we solve systems of equations. There are actually three ways to solve systems of equations. The first is graphing, second is substitution, third is elimination. We are actually not going to focus on graphing. We're going to focus on just on substitution first, and in 7.5 we'll do elimination. So let's talk about solving a linear system using substitution. Sometimes graphing doesn't give you a nice solution, like you have two graphs and you see that they cross, but where exactly they cross, if it's not at a whole number, is not exactly clear. Okay, so substitution. How does substitution work? You solve an equation, usually you're going to have two equations, like down here. You solve one equation for a variable, get the variable by itself. If y is equal to 2x, I can take that 2x and plug it in for y into the other equation. That would give me an equation with just x's. That way, when I solve that equation, I'll get a value for x, and then I can plug back in that x value to see the y that goes with it. So the main goal for this is to find the numbers by realizing that if I'm trying to find the point where these two lines cross, that if it works for one equation, it's got to work for the other equation, which means if y equals 2x here, at that exact point, y has to be equal to 2x there as well, which allows me to make the substitution. So which of these is easiest to get by itself? Probably this y, given it's already by itself. So it's equal to 2x, so I need to take 2x and substitute it in for the other y. So we have 3x plus 5 now times 2x equals 26. That's 3x plus 10x equals 26, or 13x equals 26. Divide by 13, x is 2. Okay, that's half of my coordinate. Remember, when two lines cross, they cross at a point, so that has to have an x and a y. To find my y, I take this 2 and plug it back in to the easiest equation, which is usually the one solved for the other variable. So y equals 2 times 2, which is 4. So I have 2 for x and 4 for y, and they create a coordinate point. You can always check your answers by plugging back in. 3 times 2 is 6, 5 times 4 is 20. Is 6 plus 20, 26? Yes, so it does work for our other equation as well. Now you don't always have to solve for y, you can also solve for x. Here x is negative 1 minus y, 2x plus 5y equals 7. So here, negative 1 minus y is going to go in for x. 2 times negative 1 minus y plus 5y equals 7. Distribute. Negative 2 minus 2y plus 5y equals 7. Combine. Negative 2 plus 3y equals 7. Add the 2. 3y equals 9. Divide by 3 to get y equals 3. That was a little fast. So y equals 3, but again, I take that 3, plug it back into the equation. X equals negative 1 minus that 3, which is negative 4. So that means we have the point negative 4 for x, 3 for y. Remember that x always goes first. You can check to make sure. 2 times negative 4 is negative 8. 5 times 3 is 15. Is negative 8 plus 15, 7. Yes, we already substituted it into the second equation, so it should work there. So they can get more complicated. Let's talk about potential outcomes. Let's talk about number 4. Number 3, I think you can manage. Number 4. X equals 5 minus 2y, 2x plus 4y equals 6. This is going to be a special case, and we'll see why. 5 minus 2y goes in for x. 2 times 5 minus 2y plus 4y equals 6. Here we get 10 minus 4y plus 4y equals 6. When we combine, we notice we get 10 equals 6. So when is 10 equal to 6? Never, so this has no solution. You have to ask yourself, what kind of lines have no solution? Well, when we think about it, there's only real 3 possibilities. Lines cross at one point, or if they're parallel parallel lines never cross, which is this situation here. They have the same slope. The other option is parallel lines are on top of each other and they have a whole bunch of solutions. Speaking of that, let's look at number 5. 3x minus y equals 4, negative 9x plus 3y equals negative 12. The easiest term to get by itself is probably going to be this y. So we get negative y equals negative 3x plus 4 by subtracting 3x over, divide by negative 1. We get y equals 3x minus 4. This plugs into the y in the second equation, so we get negative 9x plus 3 times 3x minus 4 is negative 12. Distribute, negative 9x plus 9x minus 12 equals negative 12. The negative 9x and 9x cancel, so we get negative 12 equals negative 12. Now when does this happen? Always. That doesn't mean all numbers are solutions. That means we have that situation where the two lines are on top of each other, which means I have what I call a free variable. Not every point ever is going to be on this line, but there are going to be at least some points on the line. And if any x value could be on that line, but there's a corresponding y value. So with substitution, it's really nice. Whatever variable you solve for is the easiest one to let the other one be free. So here, because we have y by itself, we're going to let x be whatever it wants. Y is adjusting to x. It's whatever 3 times x minus 4. So all you put in for y is whatever it's equal to in terms of x. Now, if I had solved the equation for x instead, I could have let y be whatever it wants. Let's just look at this equation. If I solve it for x instead, I get 3x equals y plus 4, divided by 3. We get x is 1/3 y plus 4/3. This is the same answer. The only difference here is I'm saying x can be whatever, and y is going to adjust. Here, I'm saying y can be whatever it wants, and x will adjust to whatever that y is. But both of these are okay. If your homework tells you to let x be the free variable, that's the one you let be itself. If it tells you to make y the free variable, that's the one you make be itself. If we've got fractions, we can manage. We can even clear the fractions. Let's say I multiply this first equation by 4 to get 12x plus y equals 8. I multiply the second equation by 4 as well. I get 2x plus 3y equals negative 10. The easiest one to solve for is probably the y in the first equation. Y is negative 12x plus 8. Substitute it in. 2x plus 3 times negative 12x plus 8 equals negative 10. That's 2x, looks like minus 36x plus 24 equals negative 10. So that's negative 34x plus 24 equals negative 10. Subtract the 24. Negative 34x is negative 34. Well, that's nice. That means x is 1. Now I have to plug back in to find the other one. Now I don't have to use one of the originals. I can use this one without fractions at all. If y is negative 12x plus 8, just plug in the 1. Y is negative 12 times 1 plus 8, which is negative 12 plus 8, or negative 4. That means I have a coordinate point 1, negative 4. That's my answer. And that is all for 7.4. We'll continue doing these types of problems using elimination in the next video.